All right, while I'm on this topic, I just want to cover one last thing real quick. It's going to be useful as well, and that is going to be converting between phase shift and time delay. Okay, so right now we have our phase shift 54.38 degrees. In both cases, it's the same, delay, but one is leading and one is lagging. So in either case, what we can do is we can actually calculate. So I talked about how, the blue signal is, it's crossing zero earlier in time than the green signal is crossing zero, right? And so there is some time associated with this, and that's often called the time delay. In this case, it's not so much a delay. I guess it's the green signal delayed by some amount of time rather than the blue signal delayed. But in this case, the red signal is delayed by some amount of time. Either way, it's a way to compute how much time there is between the two signals rather than just a phase angle. And how we do that is we basically just take the phase angle. So in this case, it's going to be, so my time delay is going to be the phase angle. So in this case, it could be 54.38 degrees divided by 360 degrees, right? So that gives me basically the ratio of a full cycle in terms of degrees. And then I just multiply that by my period, and that's going to give me my time delay. So I can go ahead and compute this in my calculator. I can say 54.38 divided by 360, and I can multiply by 200 nanoseconds because that was my my period, and I get 30.2 nanoseconds. Okay, 30.2 nanoseconds. Okay, so if that's the case, that means that this point right here would be 230.2 nanoseconds. I think I'm using the wrong pen here. It's a little thick for my liking. So let's go to this thinner one. So this would be 230.2 nanoseconds because the time delay here is going to be 30.2 nanoseconds, okay? And then this point would be 430.2 nanoseconds. So you get the point there. Well, the same would be the case on this side, except going the other direction. So I'd have to subtract 30.2. So this would be, what, 369.8. Oh my gosh, I'm so sorry. 369.8 nanoseconds, and then this one would be 169.8 nanoseconds. Okay, so that's all I wanted to cover there is time delay. And if you wanted to go the other direction, so you have the time delay, but you want to find out the phase shift, then you could just resolve this equation for the phase shift here, which clearly would just be my phase shift phi. Let me go back to the other pen. My phase shift phi would be equal to my time delay, or my 30.2 nanoseconds, divided by my period, and then I multiply that by 360 degrees. Okay, so in either case, you can determine the time delay from the phase shift, or you can determine the phase shift from the time delay, as long as you know the period of the signal, which you can determine if you know the frequency of the signal. Okay, so we're going to go ahead and end this video right here. And finally, in the next video, I'll actually get to superposition.